Hi, we're the Nebula Racing team, where stars are born. My name is Riley McBlue, and I'm the team manager.
I'm Caleb Johan, and I'm the fine art director.
My name is Rav Shah and I'm the design engineer.
My name is Chris John and I'm the resource manager.
To design our aerodynamic car, we used industry standard software called SolidWorks. SolidWorks enabled us to design our car very efficiently and also had inbuilt tools that we could use to test our car. This included the curvature test, which enabled us to see if our 6mm ball nose cutter could effectively machine our car. The wall thickness analysis, which allowed us to see if all our features and surfaces were over 3 mils to meet the regulation. We also used the mass properties tool, which allowed us to estimate the weight of the components, such as the wheel, car body, or wings, airfoils. To this, we also used the pressure test, which enabled us to see if our car could withstand the force of impact at the end of the track. We also used the flow simulation, which showed how air would pass over this car. We also investigated an analytical method called the Reynolds number. This Reynolds number is a dimensionless number which indicates whether a flow over the car, in this case we use the axle and wheel system, is laminar or turbulent. So in an F1 in schools car, we wanted this flow to be laminar. So using the formulas, we can see more detail about this formula in our portfolio. We got a number that was in the 400s. That means it was laminar. So the car that our resource manager is holding currently is our final car, and as you can see, our front wing support structure, and this is how our front wing joins. So as you can see, our car has a very long canister and has very long and a low center of gravity. This allows us to create a very aerodynamic car. Finally, our wheel support structure is a very big innovation as it is modular. That means that there is a separate axle for each wheel and not having an axle go in the middle. This allowed us to have a hollow underside and save weight and create less drag. So as you can see, our resource manager is holding Teflon wheels. Teflon is a very slippery material that allowed us to create very fast wheels. We also use full ceramic bearings from one of our sponsors, Boca Bearings, which enabled us to have more rotation in the wheels and hence create a faster F1 in schools car.
As you would have seen from the booth that you're currently standing in, we're quite fortunate to get a number of sponsors this season, including BGC, Autoplastics, and Australian Mines. We're also quite fortunate to get a number of mentors this season, including Will, a veteran from UWA who's been studying chemical engineering and data science, Matt, a student from Curtin who's studying mechanical engineering, and Ryan, a VR specialist and web developer. Communicate with sponsors, we use email, which is pretty standard. To communicate with the mentors, we use whatever was available to them, whether that be phone calls or texting or email again. We also have a website which keeps bi-weekly updates on it and make sure to keep that updated and consistent. For our ROI, we have from bronze, silver, gold, and platinum. Bronze being about 150 and platinum being about 1000, which will give you more benefits depending on how high the rank you are.
Manufacturing is a vital role of the car. After the car was machined, we began sanding. On my left, Arav is holding a 400 grit sandpaper we used. Sanding helps the car smooth, which makes the air not stick into the car, reducing slip factor. After we sanded, we began using wood putty to connect the wings and remove imperfections in the car. Then we used spray putty to make it ready to paint. Then we started painting for aesthetics. On my left, Arav is holding a black spray can we used. Arav now is going to talk about the wheel support system.
So our Teflon wheels were manufactured using a CNC drilling machine. This allowed us to effectively machine our cars, as both surfaces are circular in shape. This was effective and created an aerodynamic wheel. We then sanded our car using this system. We connected this bolt to a drill and used this 400 grit sandpaper to get rid of the edges off the wheel without reducing the diameter.
Our marketing process was very unique and innovative in several ways. Firstly, we developed our team uniform from last year's uniform. This uniform was very good because it had the green highlights and it had our other team colour, grey, without accenting our main colour of black. We also used our sponsors' logos on this shirt, which we haven't decided to do this year for tactical reasons such as reuse of shirts if sponsors change. We also had a team jacket this year, which is an improvement on last year. Our financial manager has this team jacket on. The main features of this jacket are the green armbands on the elbows and the negative space on the jacket crest with the logo and the name inside a green patch. Next, we improved our wristbands from last year. The first wristband from last year was very thin and only had the Nebula Racing slogan and name on it. This sometimes intersected with the black because we put the name in black and it could also you wouldn't be able to see the name. With the new armband, we have also added our slogan, "Where Stars Are Born," and we also have our team name again. We have changed the font, however, because it's easier to read in Arial. We changed the text to white so you're able to see it even on the black background. This year we improved on our car's paint by using Tamiya TS6 spray paints. For example, as seen on the cap of the spray paint held by our resource manager, this is Tamiya TS6. TS6 is a matte black, which is very good for contrasting with the glossy green of the car. Other marketing strategies we had included social media, and also we had several media appearances such as in the Southern Gazette newspaper and our website, googlesites.nebula racing. Thank you.